All right, last lectures of our core JavaScript lectures. So this should be the last videos for that, and then we will move forward into, depending on which course you're taking with us, we'll move into either front end specific JavaScript or back end specific JavaScript, which I am not teaching. I believe Joel Carter will be teaching that. This will be it for the core JavaScript content, and so this will be kind of the last bit of that, and then we'll see what does this look like for web developers or for server-side JavaScript, kind of whatever that ends up looking like. Obviously, I recommend learning both. I think JavaScript is really enjoyable for a lot of this stuff, even though it's a goofy language sometimes. Hopefully, by this point in the course, you've learned some about how JavaScript handles data, about data types and how dangerous those can be, the value of just keeping track of that kind of thing as you go, the difference between object-oriented and functional programming, and especially for smaller scale stuff. There's nothing wrong with using lots of functions in job interviews, right? If you say, wow, it's a complicated process, and you use 2 or 3 functions and thread them together to get your final solution, nothing wrong with that. It's actually a very wise and good way to do things because, again, a lot of algorithms are very mathy, and functional programming comes from a math background, so it actually suits that very well. So that's my little 2 cents of, I guess I'm probably at 78 cents worth of functional programming opinionated garbage, and you're probably going, all right, Brandon, enough. We know you like functional programming. Can we just keep doing this? Anyways, last lecture. It should be pretty good. Linked lists are one of the most fun, rewarding, and difficult parts of algorithm studies. I think they're absolutely fantastic. I think they're an absolute blast to play around with. Hopefully you enjoy them too. Hopefully my energy is infectious and you like it. But what we're going to do here is we're going to learn about queues and stacks, and then we'll do our linked lists, and that will be it for this kind of module. So, stacks. First up, we're going to say our stack. We're going to say let stack equal an empty array. Now, okay, so hold on. Whoa, slow down. What is a stack? A stack is, as the name suggests, it's a data structure that allows for data to follow the last in, first out principle. Think of a stack of pancakes, for example. To get the first pancake, you start with the top and you would go down. So I'm actually just going to copy this whole note over, put it in here, and I need to put this all in one reasonable spot. And do this. So this is kind of our first main note here. Okay, so last in, first out principle. This is also just another one of those vocab words that developers will use when they're talking about algos. And then I just got a couple notes to copy over here. Again, a lot of these things you can kind of figure out just kind of logically, but searching through a stack will be linear time and constant space. Selecting the last item will be done in constant time, O of 1, and constant space, O of 1, because this is just going to be the very first thing, right? If you put 3 pancakes down and you want the top pancake, it's the first thing you're going to get to, right? So it's going to be constant time always because it's last in, first out. Adding to the stack should take constant time, O of 1. Okay, so again, you put a 4th pancake on your stack of pancakes, it's going to be an immediate process. There's only one step to that, right? If you were to put that pancake at the bottom of that stack, it wouldn't really be a stack anymore the way that this is defined. But that would take a much longer time, right? You'd have to go through the entire thing. That would end up being O of n. Again, I hope that the O of n, O of 1 differences and stuff are starting to kind of clarify for you as I explain this, right? So let's stack. Let's stack. Let stack be stacked. All right, so we're going to stack.push, and we're going to pass in 10. And then we're going to say stack.push, and we're going to pass in 20. It really is this easy. And then we're going to stack.push 30. And again, we're just thinking of different ways of kind of approaching a stack. So we're going to say how to access the last value. Let's make this a nice blue. Yay. All right. How to access the last value. We're going to say let last item equals stack.pop. Okay, so that's how we would do that. I'm not going to actually run this code because it actually does remove the thing from the stack, and I want to use the stack here in a moment. But that's how you would do that, removing the last item. Again, selecting the last item should be O of 1, so it's just going to be an instantaneous thing. We don't need to loop over anything. We don't need to search for anything. It's just going to be right there. And then we could console log last item. And we're going to say searching stack in linear time and space. So actually it'll be O of n for time. And constant space. So what's this look like? It's pretty straightforward. We just write a for loop and log it out. I'm going to say, so for let I equals 0. I is less than stack dot length. This is, by the way, I talked earlier about how JavaScript just automatically clears out unused variables after it's done with them. That's called garbage collection, because they're not going to need I anymore after this loop is done. Some languages, you have to write that process on your own. You have to tell it to get rid of I, which can be very annoying, but also very powerful. But yeah, so that's why I can call I there and here. That's part of why the global scope thing works the way it does. And local scope is because of garbage collection, is that this aren't going to end up overwriting each other. That doesn't need to be a function. We're going to have I plus plus. I'm going to say console.log stack I, right? And this is going to loop over them. It's going to go through each thing. It doesn't need to save anything extra. It's not going to take any extra room, but it's going to have to go through each item one at a time, starting with 30 and then 20 and then 10, and spit them out. Actually, I think it's going to start at 10 here. But it's the same deal. And I mean, we could just say, if we wanted to start from the back, go 30 down to 10, this would just be I minus minus. And we would just say I equals, stack dot length. And this would have to be while I is greater than or equal to 0. So you just do it that way too. Anyways, so that's that one. So that's our stack. Next thing we're going to do is a queue. Let's say let q equals an empty array. Q is kind of fun to type. Q dot push 1, q dot push 2, and q dot push 3. And again, this is putting them at the beginning, right? So this is going to be in a different order. So push is going to oh no, it does the same thing. But this way we can access the first value. And this time, accessing the first value takes constant time and space. So they're both going to be O of 1. And this is going to say let first item equal q.pop 0. And again, you might be saying, shouldn't there be special methods for this? Shouldn't there be a different, with arrays have all their own set of rules for it. This is not a prototype. We're not creating a queue prototype. This is just the theory of a queue. It's the idea of something where the first thing first in, first out happens instead. And that just means that we're accessing the first value, the 0th value instead. And so here I got another note for queues here. I just have to go and scroll and find the end of the thing. Oh no. And okay, queues are similar. It's going to bug me. Queues are similar, but in this case, they follow the first in, first out principle instead of last in, first out. Think of this as a line in a Black Friday sale. The first person camped out for the big screen TV is going to be the one who actually gets it. And then I've got my little notes on, there we go, we got all that too. So same kind of thing. We've just got some different approaches to it. First item rather than last item will be constant time. And again, this is stuff that happens inside of your computer. We call it the stack when we talk about Stack Overflow. That's like the list of tasks your computer has to do. If you recurse too often, then that stack will blow and you'll get a recursion error and a stack overflow, etc. The stack is like the list of tasks your computer has to do inside of its interior guts. And that's usually, I believe, a C++ stack that it's running there. And if we were to search the stack in linear time, yeah, here we go. So this is going to be same thing here. They're just kind of opposites from one another in how they would do this, but it's the same idea, just like search looping through looping through stack in linear time and constant space. Great. So same deal. It's just going from the other direction for how we're operating the stack. And that's great. So these things aren't like super important for JavaScript. You might get asked about stacks and queues in an interview. Just they're going to say, hey, does this person know what they are? Could you write one? Again, just think of like a stack of pancakes or a queue of people waiting in line. Whoever's in front of the line gets there first. But if you're new to the line, you have to go to the end. Which is, again, how your computer has its tasks set up. Whatever the oldest thing is what it's like prioritizing. Whatever's new, it says, I'll get to that later. Cool. Well, I managed to drag that out into 10 minutes, but this next part is going to be super fun. I'm super excited about it. Let's do some linked lists. Now, quick thing on linked list theory. A linked list is where these don't have to be subsequent in memory. They don't have to be one right after another, right? And so we're not going to be super concerned necessarily with having these things right after one another, but what we're going to think of is each memory item as being a location, or it's going to be a value and a pointer to another location, right? So if I have something at location 1 and it's the letter G, but I'm pointing to location 78, which is where the value O is, and then 78's pointer is pointing to the location 7 million, and that's where L is, and 7 million is pointed to the location 5, that's where F is, and then it says no more pointers. That's how a linked list works, right? It's still a list, it's just not subsequent in memory anymore. It's all over the place. But because of that, we have to tell it where to look for the next thing, okay? So that's the core idea of a linked list, right? It's still an array. It's still a series of values, but the pointers are this added thing where it says, this is where the next thing is, then over here, then go over there. And we have to know where that is because, again, our memory, it could be all over the place. All these different values, they don't have to be in order. We could actually have them all right next to another, but out of order if we wanted to, or they could be one right after another. But the trouble is that we have to figure out how to point to the next thing. And so that's where this gets a little bit tricky, is we actually end up writing just a little bit of computer memory management here. And again, JavaScript abstracts that away from us, so we're not super afraid of having to write things like, 0x, blah, 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 right? Like, we're not going to be super concerned about writing that kind of thing. But JavaScript handles that for us, but we have to give it a nickname. We have to tell it, we have to give it a variable name to stash that. So let's go ahead and start writing this, and we're going to kind of throw it up in Python Tutor as well, and see what that looks like. We're going to use classes for this because we're going to be reusing code that has both attributes and values. There are, again, classes themselves are not evil. Objects are not evil. But that's not what I'm trying to say. That's not what functional programming thinks either. There's just different ways of solving the same problems, that some are more ornate and more smooth and efficient than others. And recursive linked list methods tends to be a pretty frequently used solution. But I'm not going to get into too much of that today because this is pretty heady stuff. And I want to get moved on to whatever comes next. So we're going to say class linked list node. And we're going to say our constructor here is going to take in a value. And we're going to say this dot value equals value. And this dot next, and we're going to default this to null, right? So when we create a new node, we don't want it to point anywhere. Okay, next is going to be our pointer. This is our pointer. And this is our value, obviously. Okay, so again, each one of these, this node is going to be represent each of our, each one of these letters. And my mouse seems to be having a hard time again. But each of these letters is going to be, again, it's instead of just one thing and it just automatically points to the next thing, sequentially. Instead, now each is going to be 2 items, and those 2 items are going to point. It's going to be a value, and then the next item is going to be a pointer to a different pairing of value and pointer, until it finds a value that the pointer's empty, and then it will be done. Okay, but this is the idea here. We haven't given it a value yet, but we could do this. We could just say like my first linked list node, and just say, let node equals new linked list node, and we're going to pass in the value 5, right? Cool, great. And so now we're going to have a linked list node where the value is 5 and it's pointing to null. So this would just be an array of value 1. It's just one linked list node. That's not super useful because the whole point of this is having multiple things. So what we're going to do is we're going to create a class linked list. And per usual, and this goes with React projects, Vue projects, whatever you're going to end up doing with JavaScript, I highly recommend if you do a big project like a framework or a data type like a linked list, write it out 5 times, right? Like do it a little differently every time. Be thinking about it, explaining it, record a video of you teaching it to yourself, and ask some questions, do some more research, look at other people's versions of this. If this is something you really want to get mastery of, I'm not going to make you write linked lists for homework, but if this is something you want mastery of, do it 5 to 10 times. And you should have a pretty good grasp on the concept and what's going on and a little bit of the rhythms that go with it. So we're going to make a class linked list, and we're going to say constructor, and it doesn't take anything. I'm going to say this.head equals null. And so that's going to be like the head is going to be the very first node on our linked list ultimately. And this dot size equals 0. Okay, so we've just given it some attributes, right? So our linked list right now has a size of 0. So this way it's a very easy way of pulling back. How long is my linked list? We'll just print out this dot size because we're going to add one every time we add a node. And this dot head right now is null because we haven't set one yet. But once we use an actual node, then we're going to replace that value. Because we need some place to start the thing. So when I say, hey, I want this linked list, it will then be able to do all the rest of the process itself. Great. So we're going to make a function called add, and it's going to take in an element. And we're going to, first we have to create a new node. And so we're going to say let node equals new linked list node. We're going to pass in element. Okay, so now whatever element we fed to the add function, so linked list dot add, is going to pass that into here as value. So whatever that element we've given it is, that becomes our value. In our node. Okay, we're going to store the current node. Store the current node. And we're going to say let current. What are we going to do about this? Well, we're going to say if the list is empty, we're going to add the current. We're going to add the element and make it the head. Okay, because we've given it this value. The pointer is still going to point to nowhere, and we don't need to give it a next thing to point to. But if we are adding an element to a list that already exists, we're going to have to loop through that list to the end of that and then add the new element on there, which we'll see in a second. But if the list is empty, if it has no length, then we're going to make this the head. So we're going to say if this dot head equals null, then what we're going to do, we're going to say this dot head equals node. And so again, the node is value and next, and that becomes the head. Because again, we're going to think of this one memory location as actually being 2 pieces of memory inside of each one of those squares, right? So our first item on our linked list is going to have 2 things in it, the value and the pointer. That's what we want to do. So the very first one on the whole thing, so we say, hey, this linked list starts at head, and then follows kind of the tail to the end. But we want to say this whole first node, the value and the pointer, go here, right? And otherwise, if the head already exists, otherwise, we're going to say current equals this dot head, and then we're going to iterate to the end of the list. And so this will say while current dot next. And that means as long as there's a pointer, right? So if this is pointing someplace, then it's going to just keep going until it hits null. And if it's not null, then it's going to add the node as the last pointer. So current equals current.next. Okay, cool. And we're going to add the node after it gets to the end of the existing list of nodes. So we'll say current.next equals node. And so again, it's going to put our new node, all of this information is going to get put at wherever next is pointing to, which is great. And then we're going to add one to size. needs to be inside of add, I believe. Yep. Which it is. All right, cool. So that's the end of add. And so we're gonna keep this pretty simple. We're just gonna have kind of the two things here. We're gonna say our next function will be print list. Let cur equals this dot head. And so this is going to say the current thing is going to be wherever it's going to start by pointing to this dot head. Again, if it has stuff in there, then this won't be null. Or again, we've actually made stuff. And this is part of the trick with linked lists, is holding all of these concepts kind of in your head all at once. But let cur equals this dot head. Let stir equals an empty string. And we're going to say while cur. So while there is a value from the head, and we're obviously going to take that head and then go pointing past that. While cur, we're going to say string plus equals cur.value plus an empty string. So we want to have a space between each of these things. And we're going to say cur equals cur.next. And again, that's going to be starting with the head, okay, because cur started out as this dot head, and while there's values there, that's great. While there's a node, we're going to point to the next node. And just keep doing that until the head is now empty, right? And so we're just going to keep doing that until my head is empty. And then at the end of that, we're going to console.log string. Great. And that should be about the end of what we're going to do here. That's a pretty simple linked list. Often people will want you to do things like write an algorithm to insert something into the linked list, or remove something from the linked list, or sometimes it's faster to be able to index from the end of the linked list, or just pull one value out of the linked list, right? What's the fifth item in the linked list? I want to print just that value out. All of the things you can do with a normal array, you can do with a linked list. The only main difference is we've created this ourselves, and the memory locations of all these nodes are not one right after another. They're not sequential anymore. So they go all over our computer memory, and we can do an awful lot with that. Great. So let's actually create a linked list and have some fun with this. If I actually go back over here, we should be able to inspect and see if anything's run here. On the page, we should have some stuff. There's our stacks and queues. Yippee. And now we're going to have our linked list. So I'm just going to console log linked list. Just so that we can see kind of where things are at. Great. And cool. So I'm going to say let my linked list equals new linked list. Okay, so now we've created one. Nice. But it's still null. There's no values in it. There's nothing there. So I'm going to say my ll.add, and we're going to pass in 5. I'm going to say my ll.add 8. And I'm going to say my ll.add 75. And it's going to do a big number for some reason. Okay, cool, great. And so now we're going to say my ll.printlist. Run that. And now we run over here and refresh the page again. We say linked list, and there's our string that gets printed out at the end. So it added those values and then printed them out one after another, just like you could print a regular array, loop over that array, and print out those values. It's the exact same thing. We just had to write all of that ourselves. And this should give you a very healthy appreciation as well for how many things like objects or arrays or prototypes that we don't have to write ourselves all the time, right? This is one of the beautiful things about programming in the 2020s, in this time where so many things are abstracted away, and there's still things we do ourselves when the situation requires it. I would personally, if you're going to use linked lists for your work a lot, you could write your own, or what you could do is you could write your own linked list module and install it across your entire computer, and then just call your linked list module when you need to. Only downside with that is what if you mess that up or you need to write a new function, etc. But that's up to you. Would just be kind of a cool thing to do. And it won't help you with interviews because they want you to write your own if you do this. But again, this is similar to our like binary search and our sorting algorithms. This is fairly advanced stuff to use in a job interview, right? And so again, using LeetCode and using especially Code Wars to kind of get up and running with a lot of this stuff, that's going to be a more realistic way to approach these problems and do some of this stuff. But that being said, that is pretty much the end of our core JavaScript content. I hope you enjoyed it. I had a lot of fun teaching it. JavaScript's a really cool language. Sometimes it's pretty goofy, but it's also extremely popular, extremely useful, extremely powerful. Lots of really cool stuff with it. Yeah, hope to see you in a later course, or maybe you're part of one of the bundled courses that we have here, and hopefully I'll see you for some more front end and JavaScript fun and in a different lecture series. So see you later.